Hello guys, this is CodeNCode and this is video editorial for the problem odd even subsequence taken from div 2 round 651D. So let's look at what the problem says. The problem says we are given an array of size n and we have to find a subsequence s of the array A of length k. So we have to find a subsequence of size k and we have to minimize the answer. And what is the answer? See, find the maximum of all elements at odd indices in the subsequence s and find the maximum of all elements in the subsequence s at even indices and then take the minimum of that, which is shown here. This would be the answer, and we have to minimize the answer. We have since we have many options to choose k subsequence out of an array of size n where k is less than equals to n. So out of all of those subsequence we have to find a subsequence such that which minimizes the answer, which minimizes this expression. Now see, if the chosen subsequence was 7, 5, 6, then the elements at odd indices are 7 and 6, while element at the even index is only 5. So maximum of these two is 7, maximum of 5 is of course 5, so minimum of these two is 5. So the answer would be 5 if this is the subsequence. Now again, what we are talking about here is that all of the element, find all of the element, take the maximum of all of the element which are at odd index, right? Now the indices we are talking about is not from array A but from subsequence S. It is possible that the first element in subsequence S is actually the 10th element in array A. Now in array A, that element is at even position because its position is 10, but in subsequence S that element is at first position, so that element will be considered as at odd index, not on even index, because the indices that we are considering are from subsequence, not from array. So it is possible that some element are at at even indices in array A, but they are in the odd indices in subsequence S. So basically we have to consider the indices from subsequence S, not from A. So what we have to do, we have to find a subsequence of length k which minimizes this expression, right? So if we have a look at this two example test cases, the first example test case, the answer first example test case is 2. We have to find a subsequence of length 3 which minimizes of course the answer, and you can choose a subsequence 4 to 6, which is this. Now see, the elements at the odd indices are 4 and 6, and element at even index is only 2. So the maximum of these two is 6, maximum is this is 2, minimum of 6 and 2 is 2 of course, so the answer is 2. So you can choose this subsequence, so the answer is going to be 2, and you cannot minimize further, so the minimum is 2. Now for the second example test case, we have to choose a subsequence of length 4. So what we can choose this subsequence 352 and 4, even though in both of the example I have taken the element which are continuous, but it doesn't matter because we are talking about subsequence, and subsequence can be non-contiguous as well, so it need not to be contiguous. Now 352 and 4, you can see the elements in the odd indices are 3, 2, and the element on the even indices are 50 and 4. The maximum from here is 50, maximum from here is 3, minimum of these two is 3. So if you choose this subsequence, answer is going to be 3, and you cannot further minimize this. So for this test case answer is 3, and for this test case answer is 2. So basically for a given n and k and an array of length k, we have to find a subsequence which minimizes the answer. We have to choose a subsequence of length k. Now we'll of course apply binary search to find the answer, the minimum cost, or the answer basically. Now if we see, we have to minimize this expression upon all of the subsequence of length k that we can find, right? So now if you see what I'm going to do, for a subsequence of length k, all of the element at odd indices, I'll be calling them as separate series, odd series, right? And the series that you can form using all of the element at even indices, we'll be calling that even series, right? So odd series and the even series. Now suppose that we are able to generate a subsequence k such that all of the element in either odd or the even series are less than equals to x, then the answer will be less than equals to x as well. Now what do I mean by that? Suppose in the odd series all of the elements are less than equals to x. That means the maximum the maximum of the element will be less than equals to x as well. If the maximum of odd series is less than equals to x, then there are two conditions for even series. Either the maximum first condition is that the maximum of even series is also less than equals to x, then of course the minimum you would find of these two will be less than equals to x as well, right? Otherwise, in the second condition, the maximum element in the even series is strictly greater than x. In that case as well, the answer will be less than equals to x, because we have to minimize this expression, and the maximum of even odd series is already less than equals to x. So the minimum of these two would be less than equals to x. So basically, if in either the odd series or the even series all of the elements are less than equals to x, then the answer is going to be less than equals to x. And this is really important. This is the basis upon which we will be building our algorithm. So make sure that you understand this series. Now again, odd series is the series that you can form by the all of the elements which are on the odd indices in the chosen subsequence of length k. Even series, we are considering this series with which we form by taking all of the elements at the even indices in the from the subsequence of length k, right? So if either in the odd series or the even series all of the elements are less than equals to x, then the answer is going to be less than equals to x. Answer, I mean the evaluation of this subsequence. So we will be applying binary search on x, and we will try to find whether the answer is less than equals to 50 or not, whether the answer is less than equals to 20 or not, right? So this will be the basis on which we will be building the algorithm, and I'll be showing you how we are actually going to do that. For example, we'll be taking this example. This is the third example test case in the problem. So this was the input and k was 4. So you can choose this subsequence and answer is going to be 3. We'll see how the answer is going to be 3. Now see, suppose you already know the answer, right? Suppose you are me and you are two persons and you already know the answer. I only know that the answer exists between 1 to 50, while you know the exact answer is 20. I do not know that the exact answer is 20, but I only know that the answer ranges between 1 to 50. And you know the exact answer is 20. So the game is, I'll be guessing the answer. I'll be telling you a number, and you will tell I'll be asking whether the answer is less than equals to this or not, and you will tell only yes or no, right? So you know the answer is 20. I do not know the answer is 20. All you will be telling is yes or no on my question whether the answer is less than equals to 50 or not. I mean whether the answer is less than equals to certain number that I choose or not. So I'm a smart person, so I'm going to apply binary search. So I know the answer ranges between 1 to 50, right? So the mid is going to be 25. So I'll be asking you whether the answer is less than equals to 25 or not. Of course your answer is going to be yes, because the answer is 20, you know that, and answer 20 is less than equals to 25. So you will telling me yes. So since the answer is less than equals to 25 that you have told me, so it makes no sense for me to ask you a question about 26, because the answer you already told me is less than equals to 25. So of course the answer is less than equals to 26 as well, 27 as well, 28 dash 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 50. So it makes no sense for me to test for 26 to 50. In fact, it makes no sense for me to ask for again the question from 25 to 50, because I have already asked for 25 and you have told me the answer is less than equals to 25. So I am going to discard the range from 25 to 50, basically mid plus 1 to mid to high. And if you know a little bit about binary search, you already know what I'm talking about. Basically, I have to update my high pointer to be mid -1 because because it makes no sense to ask a question from mid +1 to high, right? Because those are redundant questions. So now what I'll be doing, I'll be updating my high pointer to be mid -1, and mid -1 would mid was 25, so high would be 24. And now in my answer I have a notebook in which I am writing down the answer. So initially my answer was 50 because I do not know what answer would be, so I have taken the answer to be 50, which is the maximum. Now I update my answer to be 25 because you told me the answer will be less than equals to 25. So it is possible that the answer is 25 because I do not know whether the answer is 25 or not. So I cannot mark 25. If I mark 25, what will happen is that I am leaving 25 aside. If I mark 24 as the answer, I'm leaving 25 aside, but it may be possible that the answer is actually 25. So if you tell me the answer, if you tell yes on my question on some certain number mid, then I'm going to update my answer to be that mid. So my answer is 25 now. Now range is 1 to 24 only. Now of course I'm going to calculate mid again, which will be 1 and 24. The mid would be 12. So I'll be asking on 12 whether the answer is less than or equals to 12. You would say no, because you know the answer is 20 and 20 is not less than or equals to 24. Oh sorry, 12. So you would say no. So I'll be like, damn, the answer is not 12. That means the answer is not less than or equals to 12. That means the answer will not be equal. The answer is strictly greater than 12. If the answer is strictly greater than 12, that makes no sense to ask again a question on 11, 10, 9 up to 1, right? This it makes no sense, because if you ask a question on 10, the answer is still going to be no, because if the answer is greater than 12, then the answer is of course greater than 10 or of course greater than 1. So what I'm talking about here is to discard the range from low to mid. That means I'll be updating my low to mid +1. Now the low is 13 and high is 24. Now I have 13 to 24, and again I'll be calculating mid and again asking the question. So this is how binary search works. I'm asking a question and then I know for sure if you tell me yes, then I have to discard this range, because it makes no sense to ask these questions because those questions become redundant. Similarly, if you say no, then the lower part becomes redundant, and that helps us to reduce the range. And that is how binary search works. If you have no idea, if you have not seen the lectures I have taught on binary search, I will highly advise you to go and watch the lectures on binary search, and you can find a playlist called Basic Algorithms, I guess. Yes, Basic Algorithms, and in which in that lecture series I have explained how binary search actually works. So this is how we'll be applying binary search, and the person is me, or we are the person who asked the question. We are the one who are writing the code, and the person who tells you whether the answer is less than equals to x or not, we have to define a code for that, because we do not have two persons. Now see, and this is the person that will tell you, oh come on, this is the person that will tell you whether the answer is less than equals to x or not. This observation that we had, if we are able to generate a subsequence such that all of the if we are able to generate a subsequence of length k such that either the odd series or either the elements of the odd series or the elements of the even series, all of the elements are less than equals to x, then the answer is less than equals to x. So if we are asking a question on certain mid, let me show you how it will go, how we'll apply binary search on this. So we are the low is equals to 1 because all of the elements in the input will be greater than equals to 1. So low we have defined to be 1, and high we have defined to be maximum element in the input, which is 50. So high is equals to 50. Of course mid is going to be 25, and I have initialized answer to be high, which is 50. Now for what we are going to do, we already know the answer of this is 2, right? But for us there is no person which will tell us whether the answer is less than equals to 25 or not. While we were playing the game, you were the person who was telling, okay, the answer is less than equals to 25 or not. You were telling yes or no. So we have to ask whether the answer is less than equals to 25. Of course, in this case it is yes, but how we are going to identify, or how we are going to evaluate whether the answer is less than equals to 25 or not? For that we have to define a function. We'll do that. So we'll define two functions, is valid odd or is valid even. Is valid odd will take a parameter mid, which will be this one, and will return true if you can define a subsequence such that the answer is all of the elements. Is valid odd will return true if you can generate a subsequence such that all of the elements on the odd indices are less than equals to mid. This would return true. If we are able to find a subsequence of length k such that all of the elements on odd indices are less than equals to mid, that means the answer is less than equals to mid, that we have seen in the previous slide, right? If all of the elements of odd series are less than equals to x, then answer is less than equals to x. Or if all of the elements in the even series are less than equals to x, that means the answer is less than equals to x. So this function will tell you whether you can generate a subsequence of length k such that all of the elements on the odd indices are less than equals to mid. If it returns true, that means the answer is less than equals to 25, right? So let's see how this works. Now count is equals to 0. That means the number of elements in the series, in the valid series, is 0. Now we are going to run a loop from 1 to n, of course, and see whether we can generate a subsequence of length k such that all elements on the odd series are less than equals to mid or not. So first we are on the first element, which is 5. Now we are going to find the first element of our subsequence. First mean the odd element, I mean the element at the odd index. Now we are finding the element on the odd index. That means it must be less than equals to 25. So 5 is less than equals to 25, so 5 can be the first element in the subsequence. So we take 5 as the first element in our subsequence and count is for 1. Now we are going to look for the second element. Now it doesn't matter what element we have on the even indices, right? Because here we are only interested to find whether all elements in the odd indices are less than equals to 25 or not. So whatever is there on the even indices, we do not care about that. So I was pointing at 2, and at position 2 we were having 3, so it doesn't matter at position in the original subsequence that we are building the subsequence of length k. We do not care on the even indices what elements we have, so I am filling it by 3 without checking any condition. Now since the series contains 2 elements, now we have to fill the third element, and our I pointer is pointing to this. But since we are going to fill the third element, which is odd, which is at index odd, right? And we have to care about the element at the odd index. Now we cannot fill the third element with 50 because we care about the elements at the odd index. And now if you fill the element 50 at the odd index, then all elements at odd index will not be less than 25, and that is the problem. So we cannot fill 50 at index 3. So we move on. Now I is at 4, at position 4. Now this element 2 is less than equals to 25, so we can fill it at odd index. So I'm filling 2 here. Now the total number of elements in our valid subsequence is 3. Now we have to fill the element at the 4th index, and it doesn't matter what you fill at even index because we only care about the odd index. And now since I was pointing to 4, so we simply fill 4 here without checking any condition. Now we have to fill the 5th index. We have to fill the fifth element. Now 5th means odd. Odd means we care about it. If and I was pointing to here. Now the element here is 5. Can I fill it at 5th position in our series? Answer is yes, because 5th element means odd element, and so the element must be less than equals to 25. Now 5 is less than equal to 25, so I can fill it here. Now you might be wondering, we only want a subsequence of length 4. Why I have taken a subsequence of length 5? Well, if you are to return true or false, If you are able to generate a subsequence of length greater than equals to 4, then you can return true. Because if you are able to generate a subsequence of valid subsequence of length 10, but you want only of length 4, what you can do, you can remove the remaining 6 element. So the count is 5, which is greater than equals to 4, so it would return true. So now see again how we have evaluated whether there exists a subsequence of length k such that all the elements at odd indices are less than or equals to 25 or not. What we have done, for each element that we are going to fill in our series at odd index, we are checking the condition the element that we are filling here must be less than or equals to mid. Then only we are filling here, otherwise not. Otherwise we are simply incrementing I and checking for the next element. Now since we are able to generate a subsequence of length greater than or equals to 5, which is greater than or equals to 4, so since count is greater than or equals to 4, we would return true. Now it returns true, that means the answer is less than or equals to 25. And remember what we do, if the answer is less than or equals to 25, that means we do not have to check for 26, 27, 28, dash 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 50. That means you have to update our low pointer. So now high is updated to be mid minus 1, and answer would be initialized with 25, because the person that we have asked whether the answer is less than or equal to 25, whether the answer is less than or equals to 25 or not, that has told us yes, the answer is less than or equals to 25. So we have initialized our answer to be 25 instead of 50. Now we'll calculate the new mid, which is 12, and now we'll again call is valid odd and is valid even. So we are here calling is valid odd. So now again we have to generate a subsequence of length 4, and we at each odd position the element must be less than or equals to 12, right? So we are going to fill the odd position, and for loop runs from 1 to n, and we see whether this element can be filled at the current position or not. Currently I is at first position. Now can I fill this element at my first position? The answer is yes, because 5 is less than or equals to 12, so we can fill it here. Now we are going to fill the second element. It doesn't matter what value second element has, because we do not care about even indices in is valid odd. We care about even indices in only is valid even. So now 3 I can fill here without any condition check, so I filled 3 here. Now we need to fill the third element, which is the odd index element. So the next element must be less than or equals to 12, but 50 is not less than or equals to 12, so we would continue. Now we are at 2, so 2 is less than or equals to 12, so we can fill here fill 2 here. So the total count is going to be 3, and we have filled here 2. Now the next element is 4, which is going to be on even index. We do not care about that, so we simply fill 4 here without any condition check. Next element is 5, is less than or equals to 12, we can fill it here. So now again count is greater than or equals to 4, it would return true. That means we are able to generate a subsequence such that all of the elements on odd indices are less than or equals to 12. Basically it tells the answer is yes, less than or equals to 12. So again what we would do, we'd minimize, we'd update the answer to be 12, minimize the high pointer to be mid minus 1, then again calculate mid. We'd keep doing this, and finally when low is less than or equals to high, the answer will contain our original answer. So if I show you the code, this is the array which contains 2 into 10 to the power 5 number of elements, because the number of elements in the input are 2 into 10 to the power 5. This is k and n. So in the main function what we are doing here, we are reading k and n, and I'm running a loop from 1 to n and inserting all of the elements in the input array. After that we are calling the binary search, passing the low to be 1, high to be 10 to the power 9. Why 10 to the power 9? Because in the input it is clearly said that all of the elements can be from 1 to 10 to the power 9. So the highest element can be as large as 10 to the power 9, minimum element can be as low as 1. So that is why low is being passed as 1 and high is being passed as 10 to the power 9. Now again the answer is being initialized with h as explained in the slides. While L is less than or equals to h, you are calculating mid, and we are checking whether it is possible to generate a subsequence such that all of the elements on the odd indices are less than or equals to mid, or all of the elements in the even indices are less than or equals to mid. If that is true, that means we can initialize the answer to be mid, and we need to update our h to be mid minus 1, because if all of the elements on odd indices are less than or equals to mid, then asking a question on mid plus 1 mid plus 2 dash 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 till h makes no sense. That is why we are reducing the range to be mid minus 1. Otherwise, if there is no subsequence such that all of the elements are less than equals to mid, that means we have to increment our low pointer to be mid plus 1, and that is how all it is going. And finally return the answer when L is greater than h, then the answer would contain the actual answer. Now all you have to care about is this: is valid odd and is valid even. So here let us see the explanation of is valid odd. So we are initializing the sum to be 0. Sum is actually the count. Sum is actually the count, the total number of elements in our valid series. Now we are running a loop from 1 to n, and if sum modulo 2 double equals to 0, that means the number of elements filled till now are even. That means the next element that we are going to fill is odd. And if the next element we are going to fill is at odd index, that means we care about it because we are in the is valid odd. So the element we are going to fill must be less than equals to val. Val is actually the mid we have passed. So if the next element we are going to fill is going to be on odd index, that means we care about it, and hence the element must be less than equals to val. And if that's the condition, then we are incrementing the sum. Otherwise we are simply incrementing the I. If that is not the case, that means the next element is going to be placed on the even index. That means we do not care about it, so we are not checking the condition and we are simply incrementing the sum. So if sum is greater than equals to k, that means in our valid subsequence the number of elements are greater than equals to k. That means we will return true. Same goes for is possible even function. The same thing is there, so no need to explain. You can look at the code and can understand it. So this was all of this. This was all for this lecture. I think you have got how the problem is being solved. If you have any doubt or query, of course you can ask in the comment section. So thank you guys for watching. Until the next video drops, keep coding. Thank you.